In this video we're going to look at what is the greatest height that could possibly be achieved by a projectile. And again, I'm using my standard case, as I have done in the past two videos, to derive this equation. So again, I'm going to be looking in the vertical because it's the vertical height that I want to look for. And if I just look at it in terms of a suvat, so I'm going to look at a suvat vertically. And it does go back to a lot of the things that you learned in Unit 2. So the S is the displacement. I want to know what the maximum displacement would be. So this is what I would need. U, as always, is going to be the vertical component now, because we want to go the maximum height in the vertical that we can achieve. So initial velocity is U sine theta. V would be set as 0. And if you remember from our suvat, once something achieves its maximum height in the vertical, then its velocity would be 0, and that's something we did in Unit 2. Again, acceleration would be given as minus g, because that's obviously opposite to initial projection, and t we don't know anything about. So I'm left with s, u, v and a, and the suvat equation we can use there is v squared equals u squared plus 2as. I'm going to rearrange it though in terms of s straight away. So that would be v squared, take away u squared over 2a. So this will give me my maximum height achieved. So substituting in my values, v squared would be 0, minus u squared, which is going to be minus u sine theta squared, over minus 2g. Now, as you can see straight away, the negative signs would cancel, so I'll be left with s is equal to u sine theta squared over 2g, which we can then simplify out a little bit to give the maximum height in the vertical as being u squared sine squared theta over 2g. And again, you may well be asked to derive this in an examination.